This was a weekly homework, page 1 to 14, motion graphs and forces. Any doubt in question 1, 2? Page 1, any doubt? Page number 1, any doubt? Page 2, any doubt? Page 2. Page 3, any doubt? Sorry, page 4, any doubt? No doubt, page 4. Page 5, part 2, okay. Calculate the initial speed of the popcorn kernel. So we need the initial or the starting speed. No, if we need the initial speed, we cannot take u as 0. We need the starting speed here because we need at what speed it is being. Here the scale is given to you. You have to use a figure. You have to use a figure like this length is equals to 1 centimeter. So what you have to do, you can use a change, like take a center position. Take the center position. From center to center, you measure the distance d, like using a scale. This length is 1 centimeter. So if approximation, I'll use 1, 2, 3, example, 4 centimeter. This is just an example because actually actual length might be different, but say let's take an example. So it was 4 centimeter or 3 centimeter. So it was 4 centimeters. So 4 centimeter we convert into meters, 0.04 meters. And what is the energy change here? The kinetic energy transform into it here at this point it will have Ke, and at the maximum height it will have potential energy. And we assume there is no loss. So we can say the GPE, gravitational potential energy, is kinetic energy. Gravitational potential energy is mgh. Kinetic energy is half mv square. M will cancel with m. So we got gh is equals to half v square. We have the height which it moved, the distance. So we can work out at what speed it was moving, the starting speed. This is one way of doing the question. You can also use the equation of the motion as well. If you use the equation of motion, as it is going up, so it will have a deceleration minus 9.8. At the maximum height, its velocity will be 0. So final will be 0. Initial velocity we are finding. And the distance which it covered, like as we mentioned, according to scale factor, so 0.04 meter. Example, I'm not sure it is 0.04. You have to measure with the scale and then work out. So then you can use the equation 2as is equals to v square minus u square. You have the final velocity 0, you have the distance, you have the deceleration. So you can work out the initial velocity. Both will give the same result because there is no loss of energy, or its expression is due to gravity. Page 5, page number 6, any doubt? Whenever in a question, if it is not mentioned, like example, in the question, a popcorn kernel contained water heated and move upward. The photograph shows it is popping. So they did not specify anything. So when they don't specify, you will always assume there is no loss of energy. Because our formula potential energy equals to kinetic energy based on the assumption there is no loss of energy. Or even when we use the equation of motion, we consider that it is not, it says having a constant deceleration, which is minus 9.8. If there is no loss of energy or use of equation of motion, it is only valid. Equation of motion is only valid here if there is no loss of energy. Otherwise, if there was a loss of energy, its acceleration won't be constant. So we cannot use equation of the motion as well. Page 7, any doubt? Question 6. The box is placed on the top of the ramp and it is released free body force diagram is as it moved down at a constant velocity. Which two forces acting on the box according to Newton's third law? So we need a Newton pair forces. Newton pair forces, action and reaction forces are equal and opposite in direction. So a box is there. D is the air resistance. D is the air resistance, which is not the reaction force. One of the force, that is like example, the free body force diagram is there for a box as it moves downward. Which two forces acting on the box having according to the Newton third law correspond to the forces acting on the ram? So means which are picking up the pair forces. So one of the force is R because R is a reaction force. R is a reaction force of what? As the box will apply this will have this weight will have the two component. What are the weight will is not the force, weight will have the two component. One of the weight component of the weight which is W cosine theta and another component of the weight will be W sine theta. So W sine theta is trying to cause a downward motion. So which one is a reaction force of a W sine theta? F is a reaction force of a W sine theta. Because if it was not moving and it is moving at a constant speed, so the W sine theta, which is trying to cause a force in this direction, so friction is causing a force in opposite direction. Same thing, W cosine theta, which is acting downward, balances with the R. So that's why B should be the right answer. Is it clear? Not weight. Weight is because weight will have the component. The component of the weight are responsible for these reaction forces. Is it clear? How F and R, see, let's take an example. An object was there on the ground. What are the pair force? First, the weight. There will be a downward force because of the weight. So as a result, there will be an upward force from the surface. Now, it is on the inclined surface. So when it is on the inclined surface, the weight is acting downward. The weight will have the components. So it means there will be a component of the weight which is with an angle W cosine theta. That W cosine theta is downward according to surface. So there will be a reaction force R will be there. And then there's a W sine theta, the component of the weight which is dragging this down and it is balanced with a friction which is opposite. Is it clear? So that's why F and R is the right answer, not W. Won't it be F and D and R? No, D is the air resistance. The air resistance is, if you read the question, in the question they mention two forces acting on the box according to Newton third law, and we need, because it is according to the ramp, we need a free body force diagram for a box which is moving on the ramp. So with reference to the ramp, air resistance is not because of the ramp, air resistance is because of the air. The box is applying force on the air, air will apply force in opposite direction. So that's why D is ignored here. D is not considered. So in the option, we have only the one which is left is F and R. Correspondence force acting on the ramp. Air resistance is not acting on the ramp. So we just need the forces between the box and the ramp. That's why D we did not consider. In question 8, any doubt? 8 part 2. Suggests one further factor that may increase the sag of the cable. Temperature is one, and tension can affect the sag. What else? The spacing between the pylons. If we change the spacing between the pylons, the sag will also change. Like if we reduce the spacing, if the pylons are closer, then it will have a greater sag. The cable of a mass M at an angle theta to the horizontal, explain why the tension in the cable decreases as a sag increase. First, what will happen? Its weight will act downward. Okay. And the tension, example say this is a tension is also to pull. If I want in compared to the pylon, like the tension is to, if I compare tension, the direction of a tension for pylon, it will be like this. But with reference to the weight, it will be in this manner. So this is a tension. This tension will have the two components, one of the component which is with an angle and another component opposite to the angle. So the component of the tension which is with an angle, this will be equals to T cosine theta. And the component of a tension which is opposite to the angle is T sine theta. Same way, the other pylon also there will be a tension and the same angle theta is there. So it will also have the component, one is with an angle, so this will be T cosine theta, and the other one is opposite to the angle, that is T sine theta. So T sine theta and T sine theta, which are acting upward, are balancing the weight. So I can say 2T sine theta because the two are acting upward, so I add them. So 2T sine theta is equals to weight. Now they're saying, explain why the tension in the cable decrease as a sag increase. So means what will happen if I need T? What is the value of the T? T will be equals to W divided by 2 sine theta. What is the relation between the theta and the sine theta? That when you increase the value of the theta, the value of the sine theta will also increase. Weight is constant, 2 is constant, but as the angle increases, so as the angle increase, the value of the sine theta will also increase. If the value of the sine theta will increase, means denominator will be larger. If the denominator is larger, what will happen to the value of the t? The value of the t will decrease. So you can write the answer like the structure of the answer I will mention. First thing you will mention like weight is equals to 2t sine theta as we have to show. And then t will be w divided by 2 sine theta. And as the value of the theta increase, the value of the sine theta will also increase. So the denominator value will increase. So the denominator increases, the value for the numerator in the other side will decrease. Is it clear? This one? Any doubt? Yes, Mohammed Furqan. Any doubt in this? Okay. Page 8, any doubt? Page number 8. Page 9, any doubt? Question 11. First, a ball is dropped and reaches the ground after 0.42 seconds. The ball bounces and it is caught at the same height, so means there is no loss of energy. Okay? There is no loss of energy because it is caught at the same height. It was dropped. We have the time. What is the initial velocity of the ball? 0. The time is, what about the acceleration due to gravity? 9.8. And we have the time, it took 0.42 seconds. So first we'll find at what speed it will hit the ground. So v is equals to u plus at. The initial speed is 0, acceleration is due to gravity 9.8, and the time it took 0.42 seconds. So at what speed it will hit? 9.8 into 0.42. When you multiply them, 9.8 into 0.42. 4.12. Okay. So means the speed at which it hits is 4.12 meter per second. Now, for this graph, we want like, because you have to label the points as well on the graph. Say this is 0, then we have like 1, 2, 3, 4, and 5. And same thing, -1. No, total time is not 0.84. Total time is the time it take to hit the ground is 0.42. We are finding at what speed it hits the ground. When we release a ball, it hits the ground in 0.42 seconds. We are finding the speed. When we work out the speed was 4.12 meter per second. And it bounced back and it returned because this will also be 4.12 seconds. And initial velocity was 0 and acceleration is 9.8. Now, and we'll mention the time axis as well. Like example, say 0.2, 0.4, 0.6. Time scale you can label. So 0.1, 0.2, 3, 4, 5, 6, 7, 8. So at 0.42 means at this point, and it was 4.12, so somewhat here. And because if we consider the downward, it depends on you. Like example, if the downward directions you consider as positive, the upward direction will be negative. So it's up to you. If you consider downward as positive, upward will be negative. If you consider downward as negative, upward will be positive. So it's up to you, anyone you can consider. So here, when it is falling, it will have a constant acceleration. So means it must be a straight line till this point. Then what will happen, for a fraction of a second, it just bounce back. And when it, like the ball was released, then it hits the ground at 4.12 meter per second. And it also bounced back at the same speed. Why it bounced back at the same speed? Because we caught the ball at the same height. So it means there is no loss of energy during an impact as well. So if there is no loss of energy during an impact, yeah, if you consider the downward velocity as negative and upward as positive, that's the same thing. Like if I consider, say this is -1, this will be -2, this will be -3, this will be -4. So if I consider downward as negative, so my graph, I will have the same result, but the graph will start with a negative, and at 0.42, it will be minus 4.12 meter per second. Or if I consider this as positive, the downward, then my graph will be like this, first position. Then it bounced back. So if the downward I was considering, like in my graph, the downward I was considering positive, so upward will be negative. So when I draw the graph and at the same 0.42, it will have a negative velocity of minus 4.1 and it reaches back around 0.84 seconds and the speed will decrease. So I will draw like this. And I will join these 2 points because for a fraction of a second, it just changes the direction. So this will be the shape of the graph. If I consider downward as positive and upward negative, but if I can consider downward as negative, upward positive, so the shape of the graph will be opposite. Is it clear? This one? Page 10, any doubt? C1. Explain the effect of mass of a skydiver on the terminal velocity before he opened the parachute. So the relation between the terminal velocity depends on the speed. It's directly proportional to like the resistive force depends on the speed as well. If I drew a graph negative first, then positive, it still, yeah, it will be correct. It will be right. You will not lose a mark. Then what is the effect on the terminal velocity? Look, how a person reaches the terminal velocity when the weight equals to the drag. That's how you reach the terminal velocity. So what will happen if a person is having a greater mass? So weight is mass multiplied by gravity. Gravity we consider constant. So if the mass increase, the weight will also increase. So means if the weight increases, like if one person was having a 700 Newton weight, so he needs 700 Newton to reach a terminal velocity. Another person, example, his weight is say 800 Newtons. So he need 800 Newton to reach a terminal velocity. And the drag force is directly proportional to speed square. The viscous drag or a drag force on the person is directly proportional to speed square. So it means if the drag force has to be increased, so the speed should also increase. So means the person, if the mass of a person increase, the terminal velocity will also increase. Because he need more. How you write this answer, you'll mention to reach a terminal velocity, weight must be balanced with the drag force. And so the drag force must increase. And drag force can only be increased because the person is not changing the size, is only the mass has changed. So he has to move at a higher speed to have a higher drag force. So the terminal velocity will also increase. Yet time to reach the terminal velocity will also increase. Like he will take longer time to reach the terminal velocity. That's also correct. Page 11, any doubt? 11, 12, part D. Okay. The skydiver jump was being filmed by another skydiver. Both skydivers jump out of a plane at the same time. During the period of a filming, only skydiver who was being recorded opened his parachute. When viewing the recording after the jump, it has appeared as though the skydiver being filmed moved upward as he opened his parachute. Explain this apparent movement. Look, this is not the actual movement, this is the apparent movement. So, what actually happened as the two skydivers are jumping and one opened the parachute and other is not opening the parachute. So, first they both jump from the same plane, okay? As it, but the skydiver jump was being filmed by another skydiver and both jump out from at the same time. During the period of the filming, only the skydiver who's being recorded open his parachute. So the one who's being recorded, he opens the parachute. When viewing the recorded after the jump, it appeared that the skydiver being filmed moving up as he opened the parachute. So what will happen? This is skydiver. He reaches the terminal velocity. Like say both because they're filming that they reach a terminal velocity. So both skydiver reaches a terminal velocity. So both skydivers reaches a terminal velocity. Then he opened the parachute. Now what will happen? Both are moving downward, but what will happen the moment he opened the parachute, the other one, so he's having more drag force than the weight, so he will decelerate. He will slow down. So, for example, let's take a simple example in a horizontal plane that the two athletes who is having a race and they are running side by side. But if one athlete slow down and another athlete move at a constant speed, so that what he will feel that he's the other athlete is moving backward. So what actually happened is when this skydiver opened the parachute, he's having greater drag force than the weight, so he will slow down. So when he slow down or decelerate, so for a person who's moving at a constant speed, it appeared that he's moving backward. So even though he's not moving backward, he slowed down. That's why it appeared that the distance between the two skydivers will increase. So it appeared that he's moving backward. So the distribution of the marks, how you score the mark, that the skydiver with the open parachute, he will decelerate. So the skydiver who's filming is moving at a constant speed. So the distance between them will increase. That's why it appeared that he is moving upward. So that's an apparent movement. Is it clear, this one? Page 12, 13. Yeah, deceleration and the distance increase. We did this page 12, 13 in the session. Any other question or doubt? I'll share that recording as well in which we have discussed because I have another class. So I'll end the session now and share the recording.